And then if node.left is not equal to null and node.right is not equal to null, in other words, if the parent has both children, we're first going to be updating the next pointer of the left child. And if we are able to, right, if there is another parent with a set of children next to us, we can also update the right child's next pointer to point to the next family's left child. And then this is for cross-level pointers, right? If node.next is equal to null, in other words, if we're at the end of our current level, then that means that we need to have our next pointer point to the first node on the next level, which we get by calling the left child of the first node right now, because the first node is for the current level. And then we also need to update this variable by doing first is equal to node.next, or in other words, first.left. Okay, so maybe one question you might have right now is why this and this works? Because I don't really see anywhere where we set node.next, right? This works precisely because we do all of these sibling children pointers in advance when we're at the parent. So let's actually run through this example using our code. So remember that in the beginning, we set first to be root, okay? So we start at the root, and as long as the node is not equal to null, we move the root to root.next. But right now, the next pointer of the root is null because everything is initially null. And then what we do is we check if it has both children. It does. And so we set the left.next to be equal to node.right. And so that's basically creating, let me do a highlighter. That's creating this one right here. And then we check if node.next is not equal to null. It is not equal to null. Or sorry, it is equal to null, right? It is equal to null because right now, the next pointer of the root is initially null. So in that case, we don't execute this. Instead, we go to here, right? We know that we're at the end of the first level because the root is the only node on that level. So now what we do is we do node.next equals first.left. So basically root.next is equal to root.left. Okay, so that means that, oh, right here, yeah. So that means that root.next is going to equal to its left child, which means we're implementing that pointer right there. Okay, so now that we do have a next pointer for the root, we can, when we call this node.next for our next iteration, it's possible, right? It's not going to error out. So then we go to the node 1. Okay, we do the same thing. We check if it has both children. It does. And so then we set the next pointer of the node 3. We check if if node.next for 1 is not null. It is not null because we have this 2 here. And so we set the right pointer to point to that next node's left child, okay? And then we move on to node equals node.next. So now we're moving on to the third iteration of the for loop. And in the third iteration, we're now at node 2. And we check if it has both children. It does. And so now we set the left child to point to the right child, which is going to be that. And then we check if 2.next is equal to null. Well, it is, right? Because it's the last node on the current level. So that means that we need to go into the cross-level pointer update, which means that we need to point it back to the left child of the current first node on the current level. And so that's going to be this pointer right here, okay? And then we again do the same thing. So we're now at 3. Does it have both children? Yes. If so, set the left child's next pointer. And then does it have a node.next? Yes, it does. And so now set its right child pointer, okay? And then move to 4. And for 4, it's gonna fail both checks, right? It's gonna fail the check where it has both children because it only has one child. And it's also gonna fail the check where its next is equal to null because its next is not equal to null, right? We have a 5. And so actually we're not going to do anything, which is correct, right? We don't have any next pointers here to implement except for the very last pointer, which is a cross-level pointer. So we go to the node 5, do the same thing. It fails both checks, right? Because it doesn't have both children and its node.next is not equal to null. Now we're on 6, and it passes the check where node.next is equal to null because 6 is the last node on the current level. And so in that case, we need to do the cross-level pointer update, which means we're going to be updating the next to be that. Okay, so it actually does fit all of this requirements. And let me just kind of clarify the thought process behind all of that. So one thing is to kind of realize what you need, right? And sometimes it's kind of helpful to just maybe start coding some things that you know you're going to need before you really have a concrete idea of how you're going to implement them. And so what I did was I did some pseudocode, or right here, pseudocode, right? I knew that I had to do some iteration because this is a recursive / iterative structure. And I knew that I'm going to have to use the next pointer to move along in my tree. And I knew that my termination condition is going to be not equal to null because that's very standard for trees. And I realized somewhere along my thought process that I needed to keep track of the first node on the current level because of the cross-level pointers. And then I basically divided the problem into 2 parts. The first part is the cross-level pointer, and the second part is just the pointers within the same level, right? So the pointers within the same level are what I called sibling children pointers. And so that happens when you have both children, right? Because if you have only one child, as in the case of this, or no child, then you don't have to set any pointers, right? In fact, you are at the end of your binary tree. And so only if they do have both children, you need to first set the left pointer, and you can only set the right pointer if you're able to, if there is a left child for the next parent, right? So that only comes with this check. And then for the cross-level pointers, that's just a matter of using the variable that you saved and its left child to access the first node on the next level, and then also updating that variable as you go along. So that is the end of this question. I'm sorry it took so long. Hopefully you were able to make sense out of it. And also, again, there are a lot of different implementations, so please do not worry if your code is different from what I wrote.